Tissue processing is the process of removing water from tissue. So that tissue is infiltrated with an agent like paraffin wax, which makes it firm and provide it with support. So tissue processing can be achieved either by automation or by manual system. By automation, we majorly have two types of tissue processors. Number one, we have the closed system type of tissue processor, or we call it fluid transfer or vacuum system type of tissue processor. So number one, it has SPC, specimen processing chamber. Specimen processing chamber is in here. You can all come and look through. And that's where we place our specimens so that the fluids can access the specimen. Number two, we have the sealing gasket. Okay, touch is very important in 2 or 3 ways. Number one is tight air and tight fluid. Okay, so it creates a tight air and tight fluid between the chamber and literally the door itself, so that we don't have air coming in inside. Number two, this sealing gasket prevents evaporation of the processing fluids. Then we have our tissue basket. This is what carries the tissue cassette with our samples. The other key important area is the revolving valve. Revolving valve is like a rotary valve. Literally, this tubing, we have reagent containers from 1 up to 14. So once we start the machine, fluids must be transferred from reagent 1 to reagent 14. So it must keep rotating continuously from 1 to 14. So the revolving valves ensures that reagents are carried from bottle 1 to the specimen processing chamber. After the specified period of time, the reagents are taken back to the reagent container. Then it goes to bottle number 2 until the whole process is done. So the revolving valve in the closed system is equivalent to a transfer arm in the open system. The open system type of tissue processor uses a transfer arm. So the transfer arm has hooks where we put the tissue basket that carries our samples. So once you start the machine, the transfer arm raises up, moves clockwise, and transfers the samples into the reagent containers. That's why this one we call it fluid transfer, because reagents are transferred from the reagent containers to the specimen processing chamber. Whereas in the open system, tissues or samples are transferred from one reagent container to another until the whole cycle is done. The other key point, these two bottles, it has P1 and P2. When you touch on P1, it is reading bottle 1 purge. So it has xylene. Then you have bottle 2 purge. It has alcohol 100. So what is the use of these two? After processing, these containers, they have wax. Okay? Definitely, wax will solidify. So these two bottles, the reagent in there are basically used for cleaning. Purging, we are cleaning. So after processing, we come back to our machine and click on purging 1 and 2. So alcohol will be taken to the specimen processing chamber. After that, xylene is also taken there. So literally, We are cleaning the revolving valve, we are cleaning the specimen processing chamber and the tissue basket. Then the machine has 14 reagent bottles from 1 up to 14. And we said tissue processing is literally divided into 3: dehydration, clearing, and infiltration. So literally these bottles are divided into those 3. Then we have what we call enhanced heat exchanger. So ideally, dehydration and clearing is done at room temperature. But infiltration, we need heat because paraffin wax must remain in molten state to penetrate tissue, mere fact that it is viscous. However, with this modern machine, the enhanced heat exchanger is applied on dehydration and clearing, capable of warming up reagents under dehydration and clearing during their transfer to the specimen processing chamber. So the heating of these reagents up to 55 degrees centigrade to 60 degrees centigrade allows performance of faster processes, especially for very small biopsies. Then we have CF. These are charcoal filters. During processing, these reagents generate fumes, okay, which fumes are toxic. For example, the alcohols and xylene, even formalin. Because continuous exposure, research has shown that xylene can cause cancer. So the fumes generated are taken up or absorbed by the charcoal filters. Or the charcoal filters reduce fumes to a minimum safety level. The last aspect is the vacuum system, because we call it vacuum type of tissue processor. So the vacuum system is mostly applicable during infiltration. Vacuum will help us extract air from the processing chamber, because presence of air will cause resistance between paraffin wax penetrating the tissue. So presence of air slows the rate at which paraffin is penetrating what? Tissue. So vacuum helps us remove air so that paraffin wax can penetrate the tissue. However, it can apply on all. But why is it mostly applicable on infiltration? It's because paraffin wax is viscous. The rate of penetration will be slow. So to enhance it, apply a vacuum system.